The Evolution of Food and Agriculture, created and narrated by Dr. Robert Murray, Fellow of the American Academy of Pediatrics, Professor of Human Nutrition at The Ohio State University. Sponsored by the United Dairy Industry of Michigan. After this program, you will be able to identify and describe the significance of the Neolithic Revolution, the Gene Revolution, and the Green Revolution. Describe changes in American farming practices from the 19th to the 21st century, and discuss 21st century agricultural challenges.
Early humans were nomadic hunter-gatherers. They lived in survival mode, constantly foraging and hunting for food. Hominids, primates and early humans, were omnivores. Their diet was dictated by the environment and the season. They ate what was available: fruits, vegetables and tubers, nuts and seeds, leaves and sedges, grasses, and what animals they could kill or find. The Neolithic Revolution, the beginning of agriculture, began in 12,000 to 10,000 BC. During this time, humankind shifted from daily survival, hunting and gathering, to primitive farming. Farming started in the Fertile Crescent, an area especially conducive to crop production. Theorist Jared Diamond hypothesizes the development of agriculture enabled human culture to flourish and civilizations to advance. Primitive farming provided a fairly constant supply of food. People started domesticating animals to provide labor and food. They used every part for meat: hide, horns, bones, and milk. Starvation risk declined. Further, proximity to animals helped change human immunity against infectious diseases. Local climate and environment determined what plants were available for domestication. Of thousands of wild plants available, only about 200 were domesticated, and of these, only 12 species accounted for 80% of today's world food supply. Many of today's major food crops look nothing like their ancestors. An example is teosinte, corn's ancestor. Teosinte bore only a few ears, about the size of a U.S. quarter coin. Compare that to today's corn with its large ears and abundant kernels. Domestication of food crops began as people recognized and then encouraged growth of desirable species. They selected and propagated seeds from plants having traits supporting domestication. An optimal balance between seed dispersal, the movement of seeds from the parent plant, and dormancy, the mechanism preventing seed germination during unsuitable conditions. Other important traits were large or numerous edible parts, self-pollinating, weediness, the ability to thrive in disturbed fertile soil associated with human habitation, ease of propagation, ease of hulling, and annual versus perennial growth. Hominids also domesticated animals to meet human needs. The animals had to exhibit traits making them able to exist with humans. First, they had to be omnivores or herbivores, and they had to be able to find enough food in and around human settlements to survive. The dog is an exception. It's a natural carnivore, but adapted readily to eating what was available. Second, only rapidly growing animals were worth considering. People couldn't spend too much time feeding and caring for an animal until it was large enough to provide labor or food. Third, the species must easily breed in captivity. Fourth, the animals had to have a docile nature. Think cow versus American bison. Fifth, the animals must tolerate penning. They must not panic and flee when startled. Think domesticated, herd-oriented sheep versus a deer. Lastly, except for Felis catus, today's domestic cat, all the major domestic animals conform to a social hierarchy, dominated by a strong leadership. Conveniently, they recognize their human caretaker as the pack leader. Up to this point, we've discussed food sources of the macronutrients, carbohydrate, fat, and protein. The value of specific chemicals in food wasn't identified until the 1700s. Here's the story of the first inkling that food components other than macronutrients were important to health. On June 10, 1741, a British tall ship lurched into port after a gale-prolonged voyage. 43 men had died at sea, and the remaining crew suffered from a terrible sickness characterized by extreme fatigue, bruising, gum retraction, tooth loss, and skin wounds. This was scurvy, a mysterious disease only much later identified as vitamin C deficiency disease. In history's first clinical trial, physician James Lind discovered the cure to scurvy. Dr. Lind tested the hypothesis that a dietary acid source would prevent the disease. He randomized these treatments among 12 sick sailors. 1 quart of cider, 25 drops of vitriol elixir, sulfuric acid, 6 tablespoons of vinegar, 1/2 pint seawater, 2 oranges and 1 lemon, and a spicy paste with barley water. Today, thanks to Dr. Lind, British sailors are still called limeys because the addition of lime juice to their daily ration of rum was shown to prevent vitamin C deficiency disease. Limes were selected because they stored better and last longer than oranges or lemons. 2 centuries later, the application of the scientific method to help prevent and treat infectious diseases fostered a burst of scientific discovery. In just the first few decades of the 20th century, 13 vitamins and their dietary sources were identified. Charles Darwin's theory of evolution, natural selection, and genetic variation provided the foundation for the gene revolution. In the late 19th century, Gregor Mendel studied peas, discovering that some traits are dominant and others recessive. These discoveries provided the basis for his theories about genetic inheritance, furthering the gene revolution. The gene revolution arose when agricultural science began to hybridize crops through selective breeding to increase yield and nutritional quality. Although Fritz Haber is a name not widely recognized, his landmark work resulted in the Green Revolution. In 1909, Haber demonstrated that ammonia could easily be created by fixing the abundant atmospheric nitrogen with hydrogen. Using this process, nitrates, a key fertilizer ingredient, was made readily available to farmers around the world. Prior to development of synthetic fertilizer, farmers relied on natural fertilizer. These were expensive, labor-intensive, and far less effective. The Green Revolution occurred in the mid-1900s when crop productivity soared due to the availability and use of synthetic, nitrogen-enriched fertilizer. Let's look at how American agriculture and farming practices evolved over the last 500 years. In its infancy, America was a nation of farmers. In 1790, 90% of the 4 million citizens were farmers, 9 out of 10 families. They practiced subsistence agriculture, growing just enough for the farm family. They produced a variety of crops on small plots of land. By 1850, 64% of America's 23 million people were farmers. The number of farmers had dropped to 6.4 in 10 in just 6 decades. As the century progressed, farm size increased to an average of 230 acres. Farmers shifted from subsistence farming to raising crops for profit, specializing in marketable crops, tobacco, rice, and grain. By mid-century, cotton became the most important agricultural crop. 81% of U.S. exports were agricultural products. Productivity continued to increase thanks to inventions and technological advances. Icebox refrigerators improved food safety, reducing public health risk for foodborne illness. Hand power moved to horsepower. Examples are horse-drawn threshing machines, riding plows, and other mechanical equipment. Steam power and railway transportation facilitated rapid movement of crops to market. By the 1900s, the population had grown to nearly 76 million. Only 38% were farmers. Average farm size fell to 147 acres. At this point, a single farmer produced enough to support another 10 Americans, as well as to export. Agricultural products made up only 58% of U.S. exports. The federal government passed laws supporting agriculture. Examples include, in 1860 to 70, the Granger Laws regulated prices railroads and grain elevator companies charged farmers. In 1906, publication of Upton Sinclair's The Jungle exposed the horrific, unsanitary conditions in the Chicago meatpacking industry. This book precipitated passage of the Federal Meat Inspection Act. Other federal laws supported American agriculture indirectly. Passage of the Morrill Land Grants Acts in 1862 and 1890 provided financing for the creation of colleges specializing in agriculture and mechanic arts in every state. Examples include Iowa State University, Michigan State University, and The Ohio State University. The Hatch Act of 1887 gave federal funds to each land-grant college to create agricultural experimental research stations. They were to conduct agricultural research and pass along new information about soil management, plant growth, and animal husbandry. 20 years of research from these stations led to the development of disease-resistant plants, improved plant yield and quality, and increased productivity of farm animals. Here is one example of agricultural research from these colleges. At the Tuskegee Institute in Alabama, George Washington Carver taught crop rotation to refresh land exhausted after decades of growing only cotton and tobacco. He is best known for developing many novel uses for peanuts, sweet potatoes, and soybeans. In the 21st century, these are the recent agricultural trends. Fewer but larger farms. In 2015, there are about 2 million farms averaging 441 acres each. Less than 2% of the population live on farms or work in agriculture. Many farmers specialize in growing big money crops, such as soybeans, corn, and wheat. Agriculture makes a smaller contribution to the total economy. In 2014, farm output contributed $177 billion to the U.S. gross domestic product, about 1% of the GDP. Agricultural productivity continues to increase. Today, one farmer supports 100 people while still exporting significant amounts of agricultural products. Possibly the biggest controversy in agriculture today is genetically modified organisms, GMOs. GMOs are created by inserting DNA from a different organism to introduce a trait not present in the original organism. The soybean is the best-known GMO crop in the U.S. GMO soybeans have gone through 3 generations. The first improved productivity and ease of processing. The second improved nutritional quality. GMO soybeans were not particularly controversial until the production of the 3rd generation, the Roundup Ready soybean. This generation makes the soybean impervious to herbicides. Today, 92% of American soybeans are GMO varieties. GMOs and other new technologies have vastly increased world food production. Increased productivity is especially relevant. In June 2016, world population reached 7.2 billion. Almost a billion go hungry. By 2050, it's anticipated that the population will exceed 9 billion. Tragically, in spite of bountiful global food production, nearly 1/3, 1.3 billion tons of food is lost or wasted. Every year, consumers in industrialized countries waste almost as much food as the entire net food production of sub-Saharan Africa. This loss is a waste of food as well as the labor, water, energy, land, and other resources that went into its production. Climate change is another issue of the 21st century. This map shows the impact of climate change on world food insecurity and malnutrition. The first 5 months of 2016 were the warmest globally on record. Hotter temperatures reduced crop yield. Reduced rainfall reduced crop quality and quantity. This map shows how global climate change will affect global water supply. Agriculture accounts for about 70% of global water withdrawals. Lack of water for agriculture uses will reduce crop quantity and biodiversity. Although modern farming techniques have vastly increased productivity, they've also introduced agricultural pollution. Causes of agricultural pollution include retention of pesticides and fertilizers in soil and runoff into water sources, irrigation water contaminated by industrial and agricultural waste, soil erosion and sedimentation resulting from inefficient farming practice, livestock waste, displacement of native plants by invasive and novel crops. Invasive plants expose native plants to resistant diseases, pests, and weeds. Resistance to science is another worrisome obstacle. Science fiction writer Isaac Asimov said, "There is a cult of ignorance in the United States, and there always has been. The strain of anti-intellectualism has been a constant thread winding its way through our political and cultural life, nurtured by the false notion that democracy means that my ignorance is just as good as your knowledge." Resistance to scientific evidence harms the potential for global food production. The controversy over the existence of climate change is just one example. Agricultural sustainability is another critical issue. It's threatened by drought, erosion, soil exhaustion, deforestation, and salinization of soil. It's vital to use scientific knowledge to solve the agricultural challenges of today and those of tomorrow. This program summarized the rise of agriculture and its effect on civilization. I've covered the scientific advances supporting the gene and green revolutions. I also described changes in agricultural techniques and farming practices over American history. As world population increases, the challenge of agriculture in the 21st century will be producing enough food in a sustainable manner to meet growing needs.
Nutrients and Nutrition, translating them to quality food for public health, created and narrated by Dr. Robert Murray, Fellow of the American Academy of Pediatrics, Professor of Human Nutrition at The Ohio State University. Sponsored by the United Dairy Industry of Michigan. After this program, you'll be able to describe correlations between diet, disease, and health, explain controversies about the 7 countries study, define the process for creating dietary guidelines for Americans, and use concepts about diet quality to improve food intake patterns.
Because the U.S. is the wealthiest country in the world, food is plentiful and Americans consume the most calories of any other population in the world. It's no surprise that the American population also is among the most obese in the world. In 2011, more than 2/3 of adults were overweight or obese. The prevalence of diet-related chronic diseases also is high in the U.S. 5 of the top 10 diseases, heart disease, cancer, stroke, hypertension, and diabetes, are associated with diet. In the early 1900s, infectious diseases and accidents were the most common causes of death in America. Today, the availability of antibiotics and knowledge of germ theory have shifted causes of death toward chronic diseases, especially cardiovascular disease. With the containment of serious infectious diseases, medical science began to search for resolution to the nation's biggest killer, cardiovascular disease. As shown in this map, the disease remains the most prevalent cause of death among Americans. Dr. Ancel Keys, a prominent researcher, was the first to establish a link between diet and cardiovascular disease. In the 7-country study, he set out to prove the relationship between dietary fat and heart disease. His hypothesis was that the rate of coronary disease varies according to physical characteristics, dietary fat composition, and serum cholesterol levels. Today it is believed that circulating cholesterol penetrates the endothelial lining of the arterial walls, injured due to risk factors such as family history, smoking, excess body fat, or hypertension. Macrophages arrive, degrade the lipid, and engulf the remnants, but also cause inflammation within the arterial wall. This results in scarring, forming a fibrofatty plaque, which stiffens the vessel and forms a fibrous cap over the atherosclerotic lesion. Accumulation of lipid-engorged macrophages, known as foam cells, in blood vessels gradually causes local vessel narrowing. If the fibrous cap becomes unstable and ruptures, local damage and release of material can stimulate clotting, occluding the artery and leading to myocardial infarction, or in the brain, a stroke. The 7-country study was the first to produce data suggesting that, even though cardiovascular disease risk factors were consistent across cultures, people consuming a typical Mediterranean diet had a 29% lower cardiovascular mortality risk. The Mediterranean food pyramid illustrates the Mediterranean diet. The Mediterranean diet emphasizes fruits and vegetables, rich in whole grains and legumes, and olive oil, a good source of monounsaturated fatty acid. The diet features moderate servings of fish and seafood. Dairy intake is also modest. Red meats, processed meats, and sweets are eaten more rarely. Moderate amounts of wine accompany the diet. More recent reviews of the 7-country study brought to light some study flaws that throw its conclusions about dietary fat and cholesterol into doubt. Dr. Keyes did not randomly select countries to include. Initially, 22 were studied, yet he included data only from the 7 that illustrated his hypothesis in the final study, which introduced a serious bias into the study design. Researchers collected data from subjects in Crete during the period after World War II, when supplies of meat and cheese were limited, skewing the data in favor of the hypothesis being tested. Many study surveys were not completely filled out, making them unusable. Consequently, Dr. Keyes had data only from a few dozen men instead of the complete set from the representative sample of 655 initially planned. Even if the flaws in the study were remedied, this type of cross-sectional design can only show a statistical correlation between factors. It does not prove cause and effect. Dr. Keyes and the 7-country studies had enormous influence on the country's public health and nutrition policies. Responding to the growing support for the lipid hypothesis among the public, in 1977, the U.S. Senate Select Committee on Nutrition and Human Needs published the first set of dietary goals for the United States. The recommendation emphasized nutrients to avoid, particularly dietary fat and cholesterol, as a means to prevent chronic cardiovascular disease, rather than on beneficial foods to consume for optimal nutrition. Early on, opinion leaders and stakeholders had more influence on dietary guidelines than scientists. The initial recommendations to eat less of a certain nutrient, like fats, simple sugars, and cholesterol, raised the ire of stakeholders like the cattle, dairy, egg, and sugar industries. Another concern was the potential conflict of interest in the Dietary Guidelines advisory process. Because the U.S. Department of Agriculture has responsibility for supporting agricultural interests as well as public health in reference to food. In response, since 1980, the Departments of Health and Human Services and the U.S. Department of Agriculture have jointly published the Dietary Guidelines for Americans every 5 years, but they are based on the conclusions and recommendations of a committee comprised of independent expert scientists using an open, transparent process. The Dietary Guidelines for Americans provide science-based advice to the public for health optimization and to prevent diet-related risk factors for chronic disease. Federal food and nutrition education programs are informed by the guidelines. Although Americans were advised to replace dietary fat with complex carbohydrates, whole grains, fruits, and vegetables, the message got misconstrued as fat is bad and carbs are better, sparking the low-fat diet craze of the 1980s and 1990s. People sought to limit high-fat foods in their diet. The food industry responded by innovating lower-fat but higher-sugar foods as a means to maintain taste. As intake of refined grains and added sugars rose, so did calorie intake. Rates of obesity emerged as a public health crisis, as rates of diabetes, hypertension, high LDL cholesterol, and many other chronic diseases surged. By the late 1990s, it was apparent that low-fat diets did not really help control weight gain and were, in fact, no better than any other diets of equal caloric content. But the damage was done. The quality of the American diet had seriously eroded. In 2006, the USDA's Center for Nutrition Policy and Promotion created the Nutrition Evidence Library. The NEL uses a rigorous and standardized review method to evaluate and interpret scientific literature to produce evidence-based reviews. Evidence-based reviews inform expert opinion in developing the dietary guidelines. The federal government develops icons to accompany the guidelines to make them simpler to understand and more accessible for the public. The food pyramid icon was created in 1992. Today, the MyPlate icon is designed to give consumers a simple, pictorial guide to choosing healthful foods in the right proportions and portions. Appropriately, MyPlate focuses on foods to seek out, rather than on nutrients to avoid. There are at least 5 different nutrition surveillance methods for assessing diet quality. All help identify how the nation is performing against our nutrition guidelines and goals. This chart shows the average American intake in comparison to the 2010 dietary guidelines. Whole grains, vegetables, fruits, dairy products, seafoods, and oils were underconsumed, while solid fats and added sugars, refined grains, and sodium were overconsumed. Nutrition surveillance continues to pinpoint fiber, potassium, vitamin C and D, and calcium as nutrients of concern in the American diet. They each have a strong evidence base showing their beneficial role in health maintenance, and yet all are underconsumed by Americans across their lifespan. Some think that the simple answer to filling these nutrient gaps is to use dietary supplements. Food not only provides nutrients and energy, it also provides numerous phytonutrients known to maintain health and reduce risk of chronic disease. Your goal should be to eat your way to health with a quality diet rather than trying to supplement yourself out of disease. Nutritional epidemiological studies show the connection between diets of good quality, optimal health, and reduced chronic disease risk. These correlations have led to the concept of diet quality as a way to characterize healthy and unhealthy dietary patterns. Measures of diet quality assess the whole diet, not just energy or specific nutrients, against dietary guidelines as a means to measure overall healthfulness. The 2015 dietary guidelines emphasize diet quality within the pattern of one's dietary intake. The Academy of Nutrition and Dietetics clarifies the concept. Quote, "The total diet or overall pattern of food eaten is the most important focus of healthy eating. All foods can fit within this pattern if consumed in moderation with appropriate portion size and combined with physical activity. Emphasize a balance of food and beverages within energy needs rather than any one food or meal." The 2015 dietary guidelines provide some ideas for improving diet quality. The MyPlate icon makes it even easier to identify the ratios of food that should be supplied from various food groups to attain a healthy, high-quality diet. Here are some suggestions. Choose unrefined, unprocessed food when possible. Foods that are less manipulated retain more nutrients and fiber. Which of these choices are best? Michael Pollan, author of In Defense of Food, distilled the advice of nutritionists to choose food over edible food-like substances. These are items constructed from highly processed ingredients and often packaged and sold as a snack or convenience item. They're usually high in energy but low in nutrients. Phytonutrients and fiber are noticeably absent. Here's another tip. Balance eating out with eating at home. In March 2015, the U.S. Department of Commerce reported that Americans spent $52.3 billion at restaurants and bars and $49.7 billion in grocery stores. The first time spending at restaurants and bars exceeded grocery store expenditures. Eating at home is less expensive, more nutritious, and less likely to cause obesity. There are many logical reasons why people eat away from home. However, eating at home allows consumers more choice over what and how much they eat. A simple tip for good nutrition: eat plenty of deeply colored fruits and vegetables. Plant foods provide nutrients and fiber, as well as more than 25,000 different phytonutrients. Phytonutrients aren't the type of nutrients found in vitamin tablets. They are components of whole foods, but researchers believe phytonutrients are important for the prevention of disease due to their effects on immune, inflammatory, and oxidative stress pathways. Juicing, running fruits and vegetables through a machine to extract the juice, is popular. The juicing process discards leftover pulp that is rich in fiber and phytonutrients. Most Americans don't consume the recommended 25 grams of dietary fiber daily, which is why it is one of the 4 nutrients of concern cited in the dietary guidelines. Phytonutrients, many of which are bound to the fiber in the pulp, are also lost by juicing. One alternative is to blenderize whole fruits and vegetables rather than juicing them. This process retains more of the fiber and other dietary components. Even foods and nutrients commonly thought of as bad have a place in a good quality dietary pattern when eaten in appropriate amounts. The 2015 dietary guidelines recommend limiting added sugar intake to 10% of daily calories, about 12 level teaspoons. Added sugars are those added to foods or drinks by the manufacturer, cook, or consumer. Honey, syrup, and fruit drinks are also sources of added sugar. Consume added sugars that are associated with nutrient-rich foods such as yogurt or flavored milk rather than wasted in candies, desserts, or soft drinks. Trying to make drastic overnight change usually is a setup for failure. On the other hand, practical, motivating, and easy-to-implement strategies emphasizing small steps versus major lifestyle changes are more helpful. Start with your current eating pattern and make small tweaks by adding more nutrient-rich foods in place of less nutritious choices. Let's practice making incremental changes. Here's a typical hamburger: meat, bun, lettuce, tomato, mayonnaise, ketchup, mustard, pickles. How could we make it better? While the choices listed here are good for diet quality, they may seem drastic and may change the taste too much. They are also more expensive. Let's try a simple step. A reasonable small step is to choose lower fat beef, that is, more lean. Note the positive changes in fat, nutrients, and calories when you move from 80% lean to 95% lean beef. What changes can we make with the bun? A sandwich is defined as consisting of 2 pieces of bread with meat, cheese, or other filling. We can omit the middle bun that's currently part of the filling. Further, we can use a whole wheat or other whole grain bun to increase fiber and diet quality. People who prefer the taste and texture of white bread can use buns which are made from a whole grain white wheat rather than the traditional red wheat. Either way, we end up with fewer calories, less sugar, and double the fiber. Iceberg lettuce is commonly used on sandwiches. It gives a satisfying crunch, but it's low in nutrients. Selecting a dark green leafy vegetable doesn't change the calories, but it does improve diet quality. Even though the changes in vitamin and mineral content may seem small, the body doesn't need much. These small differences actually make a big difference in your diet pattern over time. Spinach, kale, arugula, and romaine are good substitutions for iceberg lettuce. The condiments on this burger can surprise you. Mayonnaise contributes richness, flavor, and moisture, so-called mouthfeel. Real mayonnaise, not mayonnaise-style salad dressing, is an emulsion of oil, egg yolk, and vinegar, high in egg nutrition. Yet look what happens to nutrient content when half of an avocado is substituted for the mayonnaise. The change in fat isn't large, but the contribution of nutrients is significant. Fresh or commercial guacamole can be used as well. This simple exercise demonstrates how making a few small swaps can still result in a great tasting burger that makes a powerful contribution to your dietary pattern. To summarize, nutritional studies clearly demonstrate the close correlation between diet pattern, health, and disease. A scientifically based, independent, and transparent process underpins the creation of the dietary guidelines for Americans, ensuring that they reflect the best scientific judgment at the time of publication. Since 2000, the main priority of our national nutritional guidelines has changed from an emphasis on nutrients to avoid toward a focus on building a healthy dietary pattern. Thinking about diet quality and the addition of more nutrient-rich foods from each of the 5 food groups is a better path to nutritional health than a sole focus on calories or individual nutrients. Improving diet quality is easier, more effective, and more efficient when small but steady changes are made over time to an individual's dietary pattern.
Nutrition in Brain Development, Bone Health, and Aging. Created and narrated by Dr. Robert Murray, Fellow of the American Academy of Pediatrics, Professor of Human Nutrition at The Ohio State University. Sponsored by the United Dairy Industry of Michigan. After viewing this program, participants will be able to explain the role of nutrition in brain development, bone health, and aging. This section covers the effects of nutrition, epigenetic factors, and adverse childhood events on brain development.
Even before parents know pregnancy test results, the fetus has already undergone significant development. At this time, the fetus is extremely susceptible to toxins. Researchers describe the exquisite sensitivity of children to lead. Compared with adults, children absorb more ingested lead through the GI tract. Lead more easily crosses the blood-brain barrier. The developing nervous system is more vulnerable to the toxic effects of lead. The figure on the right illustrates lead's toxic effects on body tissues, organs, and systems. Malnutrition and deficiency of iron, zinc, or calcium are harmful because they enhance lead absorption. These nutrition interventions can help. Calcium and phosphorus-rich dairy foods compete with lead to attach to transport proteins. High vitamin C foods bind with lead, forming a complex easy to excrete from the body. Dietary fiber adsorbs lead, enhancing excretion. Iron-containing foods and keeping food in the stomach help reduce lead absorption throughout the GI tract. Good nutritional health is critical for both parents. Unfortunately, most American men and women of childbearing age are not in optimal nutritional health. The graph shows the gap between recommended intakes and actual intakes of Americans. The concept of fetal programming links environmental conditions during embryonic and fetal development with risk of diseases later in life. The process starts with the presence of prenatal environmental factors. They can affect how the baby's genes are expressed. These components, combined with adult risk factors when the child is grown, increase the risk of adult-onset disease. Researchers use data from the tragic Dutch hunger winter to flesh out the concept. World War II caused a famine in the Netherlands during the winter of 1944. For 6 months, the populace lived on less than 1,000 kilocalories per day. Researchers examined the famine's effect among women pregnant before, during, and afterwards. They found that babies born to malnourished women had lower birth weight, neurologic damage, and poor mental performance. And as adults develop conditions such as obesity, impaired glucose tolerance, cardiovascular disease, and antisocial behaviors. Over the last 30 years, the concept has expanded to epigenetics. Epigenetics studies how environmental factors affect gene expression. These factors don't change DNA sequence, rather they affect how cells read instructions encoded on the DNA. Changes in how genes are read can affect the baby's gene expression via many systems. 2 important systems are, first, DNA methylation. That occurs when epigenetic factors tag the DNA molecule with methyl groups. Methylation can repress gene expression. Second is histone modification. Histones are proteins that act like spools. The DNA strands wrap around histones. Modified histones can wrap DNA too tightly, interfering with gene expression. These 2 systems can be activated by a number of epigenetic factors. An important one is maternal stress. Mothers suffering physical and psychological stress have elevated levels of stress hormones. These hormones ready the mother's body for the fight or flight response. They also readily cross the placenta and can cause low birth weight and prematurity. Infants exposed prenatally to maternal stress, especially during the first and second trimester, exhibit poorer cognitive and language abilities at the age of 5. Depending on the intensity and duration of prenatal exposure to maternal stress, infants may also be at a higher risk of psychiatric, mental, and emotional conditions. These conditions may be transgenerational. That is, the affected children may pass risk to future generations. Children exposed to adverse childhood experiences, ACEs, long-lasting, frequent, or intense stresses, can suffer lifelong consequences. The child may feel hopeless, helpless, and overwhelmed. He may display anxiety, anger, emotional outbursts, fear, and withdrawal. The Centers for Disease Control and Prevention published the ACE study in 1998. This landmark study, followed by at least 50 more, demonstrated the variety of effects that ACEs can have throughout an individual's life. Effects start early and build on each other. Affected children may suffer from disrupted neurodevelopment, which may lead to social, emotional, and cognitive impairment. These can lead to poor school performance, difficulty with interpersonal relations, and feelings of low self-esteem. Consequently, children may feel high levels of anxiety, depression, and anger. These mental health effects are associated with adopting health risk behaviors such as smoking, poor nutrition, sedentary lifestyle, high alcohol consumption, and higher risk sexual practices. The red arrow points out the connection between ACEs and adult-onset disease and disability. This connection can reduce quality of life and increased healthcare costs. The sum of these can culminate in disease, disability, low life potential, and early death. Exposure to epigenetic factors doesn't automatically result in irreparable damage. The negative consequences of toxic stress can be mitigated. Data from a maternal behavior among lab rats are enlightening as well as hopeful. Handling rat pups to give care or gather measurements frightens and stresses them. Their response to anxiety can be intense depending on maternal behavior. Pups of mothers who readily licked and groomed them after a stress displayed healthier behaviors as adults. They more readily explored their environment and were more curious, more sociable, and less aggressive. More importantly, they were generally healthier than pups who didn't receive similar nurturing from their mothers. These differences happen because biochemical changes in the brain relieve the effects of stress hormones on the epigenome. These positive changes also can be transgenerational. In humans, stable nurturing relationships with caring adults prevent or reverse the damage. Because the human brain does not fully form until age 25, it's possible to ameliorate the negative stress of ACEs. The earlier, the better. Community programs differ according to the context, need, and possibility. Find out about enrichment programs across the country at the website indicated here. The key points from this section are: the embryo grows rapidly in the first weeks after conception. Because the brain and organ systems develop considerably during this time, they are also vulnerable to the effects of malnutrition and toxins. Poor parental nutrition puts the child at risk for adult-onset chronic disease and disability. Fetal programming and epigenetics describe how environmental factors affect gene expression. Maternal stress and ACEs are epigenetic factors that can negatively affect a child's physical, cognitive, mental, and social development and impact lifelong health. But intervention by a caring adult and exposure to community programs can alleviate and potentially reverse these negative factors. Section 2. This section covers nutritional factors important to bone health. Bones play two important roles in the body. They provide structure needed for support, mobility, and protection of vital organs. The skeleton also serves as a depot for calcium and phosphorus. Bones constantly turn over, as small amounts are continually broken down and replaced in a lifelong process called homeostatic remodeling. An adult's entire skeleton is replaced many times throughout life, perhaps every 10 years or so. During bone growth and repair, remodeling triggers mineralization, the laying down of calcium on bone matrix to shape and structure bone. Remodeling increases bone strength by laying down new bone in response to stress. Weight-bearing activities, walking, running, dancing, and resistance exercise stress bones. In response, bones lay down more bone tissue, making them stronger. When its level is low in the blood, calcium is resorbed from bone to serve these metabolic functions. Chronic low calcium intake weakens bone as calcium is pulled from bone. Trabecular pits get larger and closer together, and bone grows brittle and weak. The left photo shows normal bone. The right shows how large these pits can become. Because calcium has many roles in the body, it is tightly regulated. Low blood levels of calcium stimulate the parathyroid gland to release parathyroid hormone. PTH raises blood calcium level by breaking down bone to release calcium, increasing GI absorption of calcium along with vitamin D and phosphorus, and reducing urinary calcium loss. When calcium levels normalize, PTH production stops, and excess PTH is excreted via the renal proximal tubule. Vitamin D is critical to bone health. it must first be activated by PTH to calcitrol. Calcitrol increases blood calcium levels by promoting calcium absorption from the GI tract. It also reduces urinary calcium loss by increasing renal tubular resorption. Vitamin D has an important role in promoting GI calcium uptake and limiting urinary calcium loss. In children, it helps prevent rickets, which occurs when mineralization at the growth plate is defective. In adults, vitamin D helps prevent osteomalacia, which arises when mineralization during bone turnover is dysfunctional. Unfortunately, hypovitaminosis D is common, especially among certain groups. Because breast milk is low in vitamin D, breastfed infants are usually supplemented with 400 IU, international units, of vitamin D per day. Other at-risk groups are people who get less than 15 minutes of sun exposure a day, are dark-skinned, older, are lactose intolerant, are strict vegetarians. Hypovitaminosis D is also common among people who malabsorb fat. Since vitamin D is fat-soluble, it is lost when fat is malabsorbed. The recommended daily intake for vitamin D is 600 IUs. The best sources of vitamin D and calcium and phosphorus are dairy products. This graph shows the gap between actual and recommended intake of dairy products. After age 4, the gap widens. Growing children must consume foods high in calcium, phosphorus, and vitamin D to support their rapid bone growth. Milk is an excellent source. It's no surprise that the 2015 dietary guidelines for Americans call for increased consumption of low-fat and fat-free milk and milk products. Some schools remove chocolate milk from lunch menus with unfortunate results. A significant number of children stopped selecting milk, and when the milk was selected, an average of 40% of it was thrown away. By age 20, the amount of bone is set. Teenagers need calcium, phosphorus, and vitamin D to build their bone bank. One more reason they don't drink milk is it makes them feel like children. Here are some more adult ways to get dairy foods. The key points from this section are: bone provides the body with structure and protection. It also is the body's storehouse for calcium. Bone absorbs and resorbs calcium during a lifelong homeostatic remodeling. Because of calcium's important roles, blood levels are tightly regulated in a process requiring parathyroid hormone and vitamin D. After age 4, Americans' intake of dairy products, rich sources of nutrients needed for bone health, drops and may become deficient. Deficiency of these nutrients puts children at risk for rickets and adults at risk for osteomalacia. Section 3. This section reviews the role of nutrition to support healthy aging. The silver tsunami poetically describes the rapid growth in number of Americans who are 65 and older. 2010 census data put the figure at 40 million, about 10% of the American population. By 2040, that figure will double. The reality of aging for many is a life marked by disability and death from heart disease, cancer, and cerebrovascular disease. These conditions reduce independence and quality of life for older Americans. But this situation is not necessarily inevitable. Good nutrition can help. Unfortunately, some older adults suffer food insecurity and outright malnutrition. Others have access to adequate energy, but overeat low-quality foods. With aging, the sense of taste, the ability to perceive umami or savory, sour, sweet, salty, and bitter, remains constant. But we actually perceive flavor through our sense of smell. Olfaction and the ability to discriminate between smells declines with age. More than 75% of people 80 and older develop major olfactory impairment, potentially reducing their desire to eat. More people over age 65 visit their doctors complaining of GI discomfort than any other age groups. Age-related biologic and physiologic changes occur throughout the gut. Older adults may experience reduced saliva production and decreased bite strength. These may interfere with eating. Neuromuscular changes, slow swallowing. Compared to younger adults, the tongue more slowly pushes chewed food into the esophagus. Esophageal peristalsis is also slower. Upper esophageal sphincter opening is delayed. This increases the risk of food residue entering the airways, causing choking and aspiration. Normally, the stomach produces hydrochloric acid, digestive enzymes, and intrinsic factor needed for vitamin B12 absorption. Production of these decline after age 70, reducing the bioavailability of calcium, magnesium, iron, and vitamin B12, and impeding digestion of macronutrients. Fortunately, aging doesn't affect the small intestinal hormone secretion or absorptive function. Older adults need less energy than younger adults due to decreased metabolic rate, loss of muscle mass, lack of activity. However, other nutrient needs remain the same. Given that most Americans do not consume the recommended amounts of necessary nutrients, it's safe to assume that older Americans don't either. Evidence shows that diets of good quality correlate with optimal health and reduced chronic disease risk. This food pyramid adapted for older adults provides a visual guide to healthy food choices. Note the flag at the top of the pyramid. It signals that older adults may need supplementation of vitamin D, calcium, folate, and B vitamins to ensure that they get enough. Water is the foundation of the pyramid. Because of normal physiologic changes, older adults are prone to dehydration. Each day, older women need about 2.5 liters of water, and older men need about 3 liters of water daily. Older people are particularly vulnerable to foodborne illness because of age-related decline of the immune system. 4 simple steps for food safety are: wash produce after purchase, avoid cross-contamination of foods, cook foods to the proper temperature, store food at the proper temperature. The USDA provides more tips in this booklet. It's available at no cost on this website. Nutrition assistance programs are offered in most communities. Many can be used together. They serve a variety of populations to get people the nutrition needed to help optimize aging. The key points from this last section of the program are: by 2040, Americans 65 years and older will make up 20% of the population. Many older Americans suffer from diet-related chronic conditions. Many suffer from some form of malnutrition. Physiologic changes of aging affect nutritional health. Energy needs decline, but other nutrient needs do not. Food safety is important for this vulnerable group. Many nutrition assistance programs are available.